Gray level slicing with background. You see the with background transfer function. Notice first of all the difference. With the background means the pixel values in between 0 to T1. The pixel values in between 0 to T1. If you observe the modification in the processed image or output image, same. Whenever it is like this, the transfer function is a linear transfer function. There is no any modification in the input pixel values and the output pixel values. And in between T1 to T2, we are going to be highlighted. And then after T2, after T2, and again same input image pixel values and output image pixel values are same. So it is the without first one is without background. It is a without background. Second one is this transfer function is with the background. Now you see the diagrams, you will get an idea. Now, if you observe this image is a fish in the water or a fish in the aquarium, whatever it is. So the this region, whatever the region, this region is a like a your selected region. So whatever that region, this range of pixels in between T1 to T2, in between T1 to T2. Whatever this water region, water this one, it is a T1 to T2. So this T1 to T2 gray level values you see in the processed image, these are all are going to be converted into white. Okay. Supriya, Adotna. Supriya, are you there? Supriya.
Yes, sir. Yes, sir. Yes, sir.
Arshita.
Yes, sir.
Advainda.
Yes, sir.
Monica. Monica, are you there? CR Fanindra. CR not a class law. CR Unava.
No, sir. Later, sir.
Okay. Sir. Now you see this remaining region. It is a this whatever the fish pixel values is greater than this T2. Whenever the pixel values of the fish is greater than T2, the output is going to be converted to black. So you see this entire region is converted into ఎలా అయిపోయింది ఇది ఎంత ఏమైపోయిందా ఏమైపోయింది సుప్రియా
Sir.
ఏమైపోయింది అంతా బ్లాక్ అయిపోయింది కదా
Yes, sir.
So it is the region without background. Now if you see with the background diagram fish, you see here whatever this range of pixel values are going to be highlighted to 1. What about remaining pixel values as it is? Is there any change here? This fish and this fish, is there any change? Supriya, Ashita,
Yes.
ఎవరు మాట్లాడదు మాట్లాడండి పట్టుకోరా 87 ఎవరు రావులెక్క ఓకే అర్చిత అర్థమైందా
Yes, sir. Yes, sir.
ఓకే సో ఇట్ ఈస్ అబౌట్ ఏ గ్రే లెవెల్ స్లైసింగ్ ఓకే next one is next transformation is a logarithmic transformation. So this logarithmic transformation already in the Wednesday class I have given a idea how the transfer function between input and output. Again you see G of m comma n means your processed image. C, some constant, a scaling factor, and logarithmic of f of m comma n means each pixel value in the original image plus 1. So this plus 1 is added. Suppose in the original image, is there any pixel intensity value is 0? We are going to get, suppose it is not there, 1 is not there. Suppose log 0, we are going to get an error. So to avoid that error, initially we have written this log 2 of f of m comma n plus 1. So for each pixel value, we are applying a logarithmic operation. We are applying a logarithmic operation and it is multiplied with c. Suppose c is equal to 1, no issue, only it is a logarithmic operation. So the transfer function curve, how it is, you will see. Now suppose I will show on this. Suppose it is for a gray level slicing. For if we apply, it is a identity quotient. Suppose the transfer function is a linear transfer function. Input and output, there is no any change. Suppose if we perform a logarithmic operation, the transfer function is like this. The transfer function is like this. Transfer function. So whatever the pixel values are going to be modified based on the log value. మనకు ఫార్ములాలోనే లాగ్ ఉంది కాబట్టి definitely in the processed image the pixel values are modified. Okay, and if we perform inverse logarithm, the inverse logarithmic is like this. Inverse logarithmic operation is going to be get like this. Okay, so logarithmic operation and inverse logarithmic operation. So about this curves, all this we have seen in the Wednesday's class. The only thing is we are going to be modified the original image. So modified image or processed image or output image definitely is going to be some good quality compared with this one. So you see in the a diagram, a simple diagram. You see, it is a small sparrow or a small bird. It is the original image. Now, if we perform a logarithmic operation on this, if we collect c is equal to 1. So if you see here, compare with this image is somewhat good contrast or bright image. Okay, Supriya, 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 Ashita,
Yes, sir.
ఓకేనా? డిఫరెన్స్ కనబడుతుందా? డిఫరెన్స్ ఐడెంటిఫై చేశారా? ఈ ఇమేజ్ కి హలో సుప్రియ.
Yes, sir.
Okay, so it is a logarithm. Next one is a gamma correction or power law transformation or another exponential transformation is also there. Like logarithmic operation, you can perform an exponential operation on the pixel values. So we know how the shape, like logarithmic operation, if we write exponential operation, that is like this exponential curve. So based on the pixel values, based on the exponential corresponding values, we are going to get the output image. Okay, some modifications, whether it may be good contrast or it may be bad contrast. The contrast is a low contrast or it is a high contrast, but there is some modification in the output image, processed image. Okay, next if we take a gamma correction or power law transformation. Gamma correction or power law. Power law means, so you see the simple formula. It is also we have seen in the Wednesday class. Again, I am repeating. This G of m comma n, it is our output image or process. ఎవరు మాట్లాడండి, don't talk. Now the image, it is the original image. This original image, for each pixel value is going to be write a gamma power. So the gamma kabatti it is a gamma correction, the power kabatti a power law transformation. So it is a transformation. We are transforming the image pixel values in the original image to the processed image. There is some modification is going to be taken place. So the gamma value depends upon the gamma value, whether it is a greater than 1 or it is a less than 1. So suppose it is a less than 1, we are going to get root terms. Suppose it is a greater than 1, we are going to get square terms, power terms. So in the here, whenever the gamma value is less than 1, so the curves are like this. The curves are like this, depends upon the gamma value. And when the gamma value is greater than 1, the curves are like this, lost transformation. So depends upon the gamma value, we are going to get a transfer function. So based on this, there is some modifications. You see some example. You see this diagram. It is a original image, a bar, and if we take this polar transformation, gamma value is equal to 0.1. So it is somewhat similar to this one. There is a contrast is less. Similar to the colors also almost similar. If we take this gamma value is greater than 1, compare with this image, it is somewhat some brighter. Okay, about the Supriya. Supriya, Supriya,
Sir. Yes, sir.
difference identify చేస్తున్నారా? Gamma value is less
Yes,
than
sir.
0.9 means somewhat compare with this one, it is a less.
Dark.
Ah,
Yes, sir.
this is somewhat brighter. Okay, it is the a power law transformation or gamma correction. So up to this, we have discussed about different point processing techniques. So the point processing techniques, first one we have discussed about identity, means input and output is same. Next, image negative. Next one is this gray level slicing or bit plane slicing or this power law transformation, or like this different operations we have performed. So in all these things, the original image, if we compare the original image and processed image, we are going to manipulate the pixels directly. We are going to manipulate the pixels directly. That is called a spatial domain operation. Okay. So next one is, next spatial domain operations are a local or a neighborhood operation. Local or neighborhood operation. So we know what is the neighborhood, the meaning of neighborhood, the relation between the pixels. We have seen, we are going to select a kernel. I will show one mask and then you will get some idea. Wait, I will show this. Is it visible? Supriya,
Sir.
is it visible?
Yes, sir. Visible, sir.
Okay. You see, it is a, it is called a small window. It is also called, it is a mask. It is also called a kernel. We have different names for this. So how the window, how the size? So the size is a 3 by 3, a minimum size for mask operations, or you can take this is a some 5 by 5, or it can take it is some 7 by 7, odd numbers. So the size of the mask must be, it has some center pixel and there is some neighborhood pixels. So how many number of neighborhoods are there here? There is a, it is a adjacent pixel, it is adjacent, these two are adjacent, these two are adjacent, these are diagonal pixels. Okay, adjacent pixels and diagonal pixels. So it is, these are all neighborhood pixels. So the word neighborhood are getting the idea. So these are all our neighbors for the center pixel. So how we are going to take these mask values? So generally you see it is a zeroth row, it is a zeroth column. It is minus one row, it is plus one row. It is minus one column, it is a plus one column. So based on that, we have allocated, it is this row is 0. So you see 0, 0, 0. This row is minus 1, minus 1, minus 1, minus 1. This row is 1, 1, 1, 1. So this row is, this column is 0, 0, 0, 0. This column is minus 1, minus 1, minus 1. This column is plus 1. So like this, we are going to get these weighted values. The weighted values is depends upon the type of the filter. The weighted values, suppose it is the average filter, or it is a median filter, or it is a high pass filter, depends upon the type of the filters. These are Gaussian filter or Laplacian filter, depends upon the type of the filter. These weighted values are going to be change. So, but it is a standard representation of the mask. So, what is the operation is going to be performed here? Now, I want to place this mask in the original. Suppose it is our original image. It is the mask. I want to place this mask to here, a 3 by 3. Here, suppose like this, I am going to place a overlapping. I am going to. There is no any missing. For this, for all pixel values, we are going to be performed. So, what is the operation is going to be done here? Whenever I am placing this mask onto the original image pixels. So the original image pixel value and weighted values are going to be multiplied and then added. So final value, the final result is going to be placed at the center pixel value of the image, So how we are going to be modified, how we are going to be modified in the original image means the convolving of these mask pixels with the mask weighted pixels, it is not pixels, mask weighted values with the original image pixels, and then if these are added, we are going to get some final response. That response is going to be placed at the center pixel value. So center pixel value is going to be changed here in the original image. So the pixels are modified in this process. So it is nothing but a filtering operation. So the center pixel value is now depends upon all these neighboring values, because suppose it depends upon type of. Suppose it is a averaging filter, we are going to average all these numbers. So the center pixel value is now depends upon these neighboring pixels. So the window techniques or mask processing, definitely the pixel values depends upon this neighborhood pixels. Now it is see how it is going to be represented in mathematical form. So it is the processed image g of x comma y is equal to summation of. Now I have taken here 3 rows and 3 columns. So -1, 0, +1, -1, 0, +1, and weighted functions, and then this original pixel value. You see from this equation, you will get an idea. What is this f of x plus y, comma y plus j? These are original pixel values. So what is this wij? Mask weighted values. So these are going to be multiplied and then added. So it is nothing but the convolution operation in discrete. So we are going to get the change in the original pixel intensity value at the center pixel. Like this, we are going to place and do the same operation, do the same operation. So for entire rows, all the pixel values. So finally, is there any noise? That is going to be removed by using this process? Okay. It is the I am showing only for our understanding purpose. This is the shape of the mask. Okay. Okay, is it visible? Hello, Supriya,
Sir,
is it visible?
yes, sir, visible, sir.
అర్థమైందా చెప్పింది తెలుగులో
Yes,
చెప్పారా?
sir.
ఈ మాస్క్
అర్థమైంది, sir, అర్థమైంది.
లో ఉన్న వాల్యూస్, ఇమేజ్ లో ఉన్న పిక్సెల్ వాల్యూస్, ఓవర్లాపింగ్ పిక్సెల్స్ 9 పిక్సెల్స్ ఓవర్లాప్ అవుతాయి కదా, అవి మల్టిప్లై యాడ్ చేసిన తర్వాత వచ్చే వాల్యూ, the value is going to be modified in the center. మీ ఒరిజినల్ పిక్సెల్స్ లో 9 పిక్సెల్స్ లో సెంటర్ పిక్సెల్ లో ఆ వాల్యూ రీప్లేస్ చేస్తాం. Like that, it is going to be performed for all the pixels, same operation. So that is the meaning of local or neighborhood operation for any type. It is a low pass, or it is a high pass, or it is a median filtering. Whatever the type of filtering, the concept is same. So you see here the statement, the neighborhood operation. What is the neighborhood operation? The pixels in image. The pixels in the image. You see that statement. Whatever the original image, in that original image, whatever the pixels you have, that the pixels in the image are are modified based on the some function of the pixels in their neighborhood. What is the meaning of some based on some function means? It may be averaging, or it may be median, or it may be a high pass, depends upon the type of the function. So based on that, these are going to be modified. It is depends upon the neighborhood, depends upon the neighborhood. Okay, a neighborhood pixels, the value is depends upon. Linear spatial filtering is often referred to as convolving the mask. Convolution operation is going to be performed there. Convolving a mask with an image. So original pixel values and mask weighted values are going to be convolved, and then these are all are to be added, and whatever the response, that response is going to be modified in the original center pixel. So like that, this operation is going to be performed for all the rows in the original image. So the pixel values are going to be modified. So the filter mask are sometimes called convolution mask or convolution kernel. Okay. Now coming to the spatial filtering, why the word spatial? We are performing on directly on spatial coordinates. That's why we are performing the filtering operation. So the name it is a spatial filtering. So spatial filtering involves passing a weighted mask. See, spatial filtering involves passing a weighted mask. We are going to be considered a weighted mask or kernel. It is also called a kernel over the image. Image lo ఉన్న pixels ki ee kernel lo ఉన్న weighted values are going to be convolved and replacing the original image pixel value corresponding to the center of the kernel with some of original pixel values in the region corresponding to the kernel multiplication by the kernel weights. So whatever the pixel values we have, that pixel values and kernel weights are going to be convolved, are going to be multiplied, are going and then added. Whatever the value, that value is going to be modified. So it is the way of getting this modification. So you see the type of filterings. We have a first type is a mean filter. Mean means average value. So or you can also call it as a averaging filter, or you can also call it as a low pass filter. The meaning, you don't confuse here. Low pass filter anna, average filter anna, mean filter anna, these are all are similar words. It generally filter anangane you have a little bit of confusion. Usually filter means it is a frequency domain. Yeah, because suppose it is a low pass filter, it allows only low frequencies and attenuates the high frequencies. So suppose it is a high pass filter, it allows only high frequencies and attenuates low pass filter, low frequencies. Now here, the low pass filtering operation, we are going to be performed on spatial coordinates. It is not related to frequency domain. Now again, there is another type of technique. There is a frequency domain technique is there. In that frequency domain technique, after performing the Fourier transform, we are going to get frequency domain coefficients. On that frequency domain coefficients, we are going to perform this low pass filter operation. That is the frequency based. Now here, whatever the low pass filter, you don't confuse here the word filter. Low pass filter means here we are going to be performed directly on the pixel values. That is the low pass means here averaging. We are doing the mean value or averaging value. Averaging means, you remember, low pass averaging means just we are going to be added. So you see the definition here. The mean filter, you see the mean filter replaces each pixel by the average value of all the values in the local neighborhood. Average value of local neighborhood. Local neighborhood means suppose it is a center pixel. These are all our neighborhood. So this pixel value is going to be modified. This pixel value is depends upon based on all these values. Okay, that is the meaning. The mean filter replaces each pixel by the average value of all the values of local neighborhood. So the size of the neighborhood controls the amount of filtering. So the size of the neighborhood controls the amount of filtering. Enta amount lo enta value modify avutundi depends upon the size. It is a 3 by 3. Almost there is no a drastic change. Suppose if we take a 5 by 5. Suraya, ఎవరు మాట్లాడింది? ఎవరు? సుప్రియ,
సార్
ఎవరు మాట్లాడింది?
చూస్తున్నాను సార్.
ఇప్పుడు చూసి
ఎవరు లేదు సార్, అందరూ మైక్స్ ఆఫ్ లోనే ఉన్నారు.
Okay, na? So, control depends upon the size of the mask also, it depends upon this value. Okay, suppose 3 by 3, there is no drastic change. If you take 5 by 5, somewhat change. If you take 7 by 7, because we are going to consider 7 sevens are in the 49 pixels we are going to consider. So some pixels are going to be same pixel value, some pixels are going to be some different pixel value. So the value is going to be affected. The size of the mask is changes. Size of the mask is increases. The pixel values are going to be somewhat drastically changes. Suppose if we take this 3 by 3, so there is no a drastic change here. Okay. So on an average, even some change is there. Suppose one pixel value is 25, another pixel value is 50. Remaining all pixel values are around 25. Even that 50 is also on an average, we are going to get nearer to the 25. So that is the purpose here. So in a spatial averaging operation, each pixel is replaced by a weighted averaging of the neighborhood pixels. That is, a low pass filter preserves smooth region. The purpose of, you see here, the purpose of low pass filter is preserves the smooth regions in the image. Smooth regions means what? Smooth regions means there is no drastic change, there is no abrupt change. So suppose 111, we can say it is a smooth region. Suppose if we take 11111, it is called smooth region. So suppose here there is a one next pixel. Suppose there is a some 200 is there, so it is not a smooth region. Okay, so whatever there is wherever in the region there is a non-smooth regions, that non-smooth regions are going to be converted into smooth regions. So that is the meaning. The low pass filter preserves the smooth regions in the image, and you see this word also removes the sharp variations. ఇప్పుడే చెప్పాను, షార్ప్ వేరియేషన్స్. షార్ప్ వేరియేషన్స్ అంటే ఏంటి? ఎనీ పిక్సెల్ వాల్యూ ఈస్ డ్రాస్టికల్లీ చేంజెస్, suddenly changes, abruptly changes from suppose from 10 to 150 or 10 to 100. There is a sudden change. So whenever there is a sudden change in the pixel values, that is going to be removed. So that is the meaning. So it removes the sharp variations. So because of this process we are doing, we are going to get some blurring effect. So whenever we are doing one operation, one advantage is there, simultaneously there is some disadvantages there. So what is the advantage here? The advantage is here, whatever the sudden variations, abrupt changes, that is going to be removed. So because of removing these sudden changes, the region is going to be converted into smooth. At the same time, it leads to a blurring. Some blurring is going to be occur. So how we are going to perform, how we are going to take this overall intention of this low pass filter is smoothing the region. Is there any abrupt changes? Is there any sudden changes? That sharp variations, అంటే నేను ఇప్పుడే చెప్పాను 10 to 100, 10 నుంచి 100కి మారిపోతే ఇట్ ఈస్ అ షార్ప్ వేరియేషన్. సపోజ్ 10 to 15 ఆల్మోస్ట్ నియరర్, 10 to 12, 10 to 5, these are all are nearer. So there is no any problem with that. Whenever there is a sudden change, it is usually called some noise is added. So that noise is going to be removed here. So that is the meaning. So the type of how we are going to take these masks. ఇంత ముందు స్లైడ్లో నేను చూపించిన స్లైడ్లో కూడా there is a mask processing. So the type of the mask here you see for averaging filter, a 3 by 3 size. We see this 3 by 3 size. So this 1 by 9 means depends upon the size, 3 rows, 3 columns. So 1 by m into n. So m rows, n columns, m rows, 3 rows, 3 columns, we are going to get 9. So all these weighted values in this window, in this kernel, all these weighted values, center pixel is 1, neighborhood pixels are 1, this neighborhood row neighborhood pixels are 1, column neighborhood pixels are 1, diagonal pixels are 1, all neighborhood pixels are all are ones. So it is the standard kernel for averaging filter or low pass filter or a mean filter. Are you getting? And you can take other size window. So the size window I am going to change from we need to consider, we need to remember only odd numbers, because there must be center pixel. We require a center pixel and neighborhood pixel. So here also it is a center pixel, and neighborhood pixels. These are all are neighborhood. Anyway, these are connected for first row connected and secondly connected. So the what is the size 5 into 5? You are going to get 20. All are ones. Suppose even if you want to take 7 by 7. So 7 by 7, 7 into 7, we are going to get 49. And we are going to get all are ones. So if we add these all are ones, we are going to get 9 again. If we add all